In this video lecture, we are going to discuss about a gamma decay. Gamma decay is a radioactive decay. In gamma decay, an excited daughter nuclei, which is unstable and it is excited, it goes to its de-excited state by releasing high amount of energy in a form of gamma rays is known as gamma decay. Or in a simple word, gamma decay is a nuclear de-excitation of daughter nuclei result into release of highly energetic gamma radiations. So now, dear student, let us write a definition of gamma decay. Gamma decay is a process in which unstable radioactive daughter nuclei jump from excited state to ground state release an energy in a form of gamma rays is known as gamma decay. So if I represent gamma decay schematically, consider that we have a nucleus. As you know that in nucleus there are protons and as well as neutrons. Suppose this is a nucleus and it has protons and as well as neutrons. And we suppose that this nucleus is basically it is a daughter nucleus and it is in excited state. So in order to represent a nucleus in excited state, we use the symbol steric. So now this nucleus is in excited state and it has very high energy. So now in order the nucleus basically prefer to stay or remain in a ground state. In order to nucleus to come to ground state, the nucleus from this excited steric state will basically jump to a ground state. This is basically a rough representation of a nucleus. You can basically but please imagine or consider that this is a same nucleus as nucleus which is in excited state, so both images are same. So this is neutron, 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 and this one is proton, proton, protons, proton. So this basically from excited state this nucleus jump into a ground state. So the ground state is represented by Eg and excited state is represented suppose by E excited. So when the nuclei jump from excited state to ground state, e.g., nuclei will basically release highly energetic photons, and these photons are basically known as gamma rays. The energy of the gamma rays depend on the energy of the photon. Depend on sorry on the frequency of the photon, and the frequency of gamma rays during the nuclear de-excitation is around 10 raised to power 18 to around 10 raised to power 19, which means that since you know that E is equal to H into nu, this means that energy of gamma rays, E of gamma rays is too much. And usually the energy of gamma rays is in a range of 100 kilo electron volt to few mega electron volts. This is humongous or huge amount of energy. So during the nuclear excitation, de-excitation, huge amount of energy in a form of gamma rays is released. Listener, please keep in mind that the gamma nuclear de-excitation is just like same. It is just like a de-excitation of electron in a shell. Since you know, then an atom consists of a nuclei, and nuclei has protons and as well as neutrons. Around the nucleus, there are energy levels, and these energy levels are basically known as shell. Lowest energy level or ground state energy level or low energy level is known as K shell. Slightly higher energy level than K shell is known as L shell, and more energy level higher than L shell is known as M shell. M shell. The electrons are present in these energy levels or in these shells. Suppose these are the electrons. So now, if these electrons are gain an energy, or energy is given to these electrons from somewhere from outside, then when these electrons gain energy, the electron have more energy, so they will jump from this ground K shell or from low shell to higher energy level or L shell. So now, when electron jump from low energy level to higher energy level, it means that electron have gain energy. Electron have higher energy than the lower energy level shell K shell. In case if the electron releases energy from a K shell, from higher energy level L shell, uh, and then when the electron release energy, the energy of the electron which is present in L shell uh, is basically it is decreased, and due to release of energy, the electron will from L shell will jump into K shell, and due to the electron jumping from higher energy level to lower energy level, the radiation released are known as X-rays. So basically, gamma rays is also a same kind of transition like X-rays, but gamma rays are basically produced due to transition of nuclei from high energy state to low energy state, whereas in X-rays it take place due to transition of electron in energy levels or in shells. This is basically difference between a transition of gamma between a transition of nuclei and shell, which are produce gamma rays and as well as X-rays. Now, dear student, please keep in mind that energy of X-rays is less than gamma rays. Energy of X-rays is around 100 electron volt to 100 kilo electron volt, whereas energy released by gamma rays is in the range of 100 kilo electron volt to 100 of mega electron volt, which means that gamma rays are very energetic than X-rays. So we can write that the energy of gamma rays is way more than the energy of X-rays, though processes have some kind of relevancy, but the energy difference in these two processes, which basically produces X-rays and gamma rays, is too much. Now question here is that how nucleus is how nucleus is excited. Now there are two ways for exciting a daughter nuclei or nucleus of an atom. One way is a collision of an atoms, and second way of excitation of nuclei is radioactive decay. So by these two ways, a nucleus is basically excited into its unstable excited state. So dear student, please note that there are different types of radioactive decay, such as alpha decay, beta decay, and positron decay, etc. However, the gamma particle or gamma decay usually take place, or gamma particles are produced mostly by beta decay. They may be produced by positron decay and alpha decay, but mostly gamma rays are generated or produced by beta. Since you know that in beta decay, suppose we have an element having an atomic number, have an element X having atomic number Z and as well as atomic mass, uh, atomic mass A. So now this element is going through a gamma decay. So initially this element will be excited, the nuclei of this element will be excited and it will go to excited state. So in this excited state we will represent it by asterisk, and when this element go to excited state, in order to have a gamma decay we need to de-excite this element, and in order to de-excite the nuclei of this element, the de-excited element will be de-excited by jumping from excited state to its ground state, and in this way, by jumping of element in from excited state to ground state, they will basically release gamma particles. Now in case of beta decay causing the release of gamma particle, you know that suppose we have an element X having an atomic number Z and as well as mass number A, and it is going through a beta decay. So you know that in beta decay a proton a neutron, N, is converted into proton. And as we know that atomic number Z is basically number represent a number of proton or number of electron. So this means that atomic number, the neutron is converted into proton. So the atomic number of new atom will be, or new nuclei will be one more. So suppose the X during a beta decay is converted into an element, into another nuclei Y, so the atomic number of that new atom will be Z plus 1. Since in the transformation of a neutron into proton, the amount of proton basically increased, but the atomic weight is basically, it is a number of proton plus neutron. So this means that total amount of proton and neutron of daughter and parent nuclei, parent and daughter nuclei will remain same, which means that atomic weight of both parent and daughter nuclei will remain same. And in this way they will basically release beta particles, and along with the beta particle gamma rays will be produced. So in this way, in a beta decay, basically gamma radiations are produced. Now students, consider the example of gamma decay by doing a beta decay of uh, cobalt element. Consider that we have cobalt C60 and the nuclei of this cobalt atom is in excited state. So let us represent the energy diagram for beta decay of the cobalt, which basically cause generation of gamma particle or gamma rays. Suppose this is excited state of a cobalt, so E excited. So since you know that if cobalt is going through a better beta decay, the cobalt atomic number of cobalt is 27, and whereas atomic weight of a cobalt is 60. So in beta decay, atomic number is basically increased by 1. So atomic number of new element will be 28, whereas the atomic mass of new element remains same. So if we check the periodic table, atomic number of an element, 28 of an element is basically, it is a nickel. So cobalt is basically, it is transformed in beta decay in nickel, and during the transformation it's also released beta particle plus gamma rays. So now let's do the transition of a cobalt into a nickel, stable nickel atom. Suppose that this is a ground state for nickel, ground state energy Eg for nickel 60. Before reaching the nickel nuclei into ground state, there are basically two excited states between the ground state of the nickel. So one state, this one is known as this one is basically known as first energy state, and this one is basically second energy state for a nickel nuclei. So now when cobalt in excited state go into a beta decay, basically it releases a nickel, it produces a nickel nuclei, and these nickel nuclei will prefer to go to second energy state, second excited energy state. And after going to second excited energy state, then the nickel nuclei which is in second excited energy state will go to first excited energy state, and then again in order to get stability from second excited state to go to first excited, then from first excited state nickel nuclei will basically go to a ground state. So in these transitions from second energy state to first energy state, there will be a release of gamma rays. And similarly, transition of nuclear nickel from first energy state into a ground state, there will also be release of energy in a form of gamma rays. Children, please keep in mind that 99.9% transition of nickel nuclei from excited state basically take place in second excited energy state, and energy released is in second excited energy state is around 2.5 mega electron volt. Okay, and then from second energy state to first energy state, the energy released is around 1.33 mega electron volts. So now, this student, please keep in mind the total energy released in a nuclear de-excitation is around 2. We can calculate it from that 2.5 mega electron volt to minus 1.33 mega electron volts. So net amount of energy released a, due to a gamma decay will be around 1.17 mega electron volts. So this is basically huge amount of energy during the transition of a cobalt C60 into a nickel 60. So if I conclude the energy level diagram for gamma decay, basically initially a radioactive nuclei is basically is excited, and it's go to excited state, and after the excited state, radioactive nuclei is not stable at excited state, it go to a ground energy states, and in a ground energy during the transition from excited energy state to a ground energy state, nuclei basically release highly energetic gamma rays. So now, student, please keep in mind that the lifetime of de-excitation from second energy state to first energy state, or from first energy state to ground and level, is very short, and it is in the range of 10 raised to power minus uh, 9 to 10 raised to power minus 12 seconds. Now, keep in mind that if the lifetime increases from this very small time to 1 second, uh, or 1 day, or even more like 1 year or a month, then such type of radioactive transitions are known as nuclear isomers, or such types of state in which lifetimes basically increases and it is too much, then such types of states are basically known as nuclear isomers. Basically, nuclear isomers are energy states having a long lifetime. So this is all about gamma decay. Gamma decay is a process of nuclear de-excitation of a daughter nuclei from its excited state to ground state. So when a daughter nuclei de-excites from excited state to ground state, it releases gamma radiations. And the process in which a daughter nuclei from its excited state releases a gamma rays and reach to a ground state is known as a gamma decay. So this is all about the gamma decay. So dear students, thank you for watching this lecture.